In the quiet stillness of deep space, a spacecraft drifts silently against the black canvas of the cosmos. Inside, astronauts float effortlessly through the cabin, weightless, graceful, and slowly deteriorating. Muscles shrink, bones weaken, and even the heart begins to strain in a body untethered from gravity. For all the wonder of space, one thing becomes clear: human beings weren't built for weightlessness. Gravity isn't just a force, it's a constant companion. On Earth, it shapes our physiology from birth. But in orbit, we become strangers to it. Without gravity, blood shifts upward, eyes swell, and coordination falters. The longer we stay in space, the more our bodies begin to forget Earth. And as we set our sights on Mars, the Moon, and beyond, one question demands an answer: can we bring gravity with us? This is where the idea of artificial gravity enters the scene, a concept once confined to science fiction, now increasingly central to real-world space exploration. It refers to the creation of gravitational effects in an environment that naturally has none. Not just for comfort, but for survival. For future astronauts spending months, or years, away from Earth, artificial gravity could be the key to preserving bone density, cardiovascular health, and even mental stability. Without it, the dream of deep space becomes a ticking biological clock. But how do you recreate something as fundamental and invisible as gravity? That's the challenge. On Earth, gravity is a product of mass. In space, where adding mass isn't exactly efficient, scientists have looked elsewhere. One of the most promising approaches is rotation. Just as a spinning ride at a carnival pushes you outward, a rotating space station could use centrifugal force to mimic the feeling of weight. The faster the spin, the stronger the force. The trick is finding the right balance. Too fast and you risk dizziness, nausea, and disorientation. Too slow and you lose the effect entirely. Other methods, like magnetic fields and linear acceleration, have been explored, but they come with their own set of limitations. Magnetic solutions could potentially manipulate the movement of fluids in the body, but they remain experimental and difficult to scale. Meanwhile, constantly accelerating a spacecraft to simulate gravity is technologically complex and fuel-intensive. Each method opens a door, and then immediately reveals how many more must be unlocked. Still, progress is being made. NASA has experimented with short-arm centrifuges that simulate gravity on specific parts of the body, spinning astronauts in a controlled environment. On Earth, machines have replicated gravitational loads for training and rehabilitation. The International Space Station, while not equipped with artificial gravity, has hosted many of these studies, gathering critical data. And in the world of engineering, researchers are already designing rotating habitats, wheel-shaped stations that resemble scenes from science fiction films but are slowly inching toward reality. The concept of space tethers, long cables that rotate to generate artificial gravity, is also being explored as a potential bridge between today's limitations and tomorrow's possibilities. And while true gravity generators remain hypothetical, the groundwork being laid today may one day lead to technologies that fundamentally reshape life in space. If you're finding this as fascinating as we do, now is the perfect time to show your support. Hit that like button, subscribe to stay updated on the latest breakthroughs in space science, and ring the bell so you never miss a moment of discovery. The promise of artificial gravity reaches far beyond comfort. It could unlock long-duration missions to Mars, make life possible on lunar bases, and even enable sustainable agriculture in space. Imagine astronauts waking up to exercise under their own weight, harvesting fresh vegetables grown in rotating greenhouses, or sleeping without the disorienting sensation of floating. Artificial gravity may be the missing puzzle piece in transforming hostile space environments into livable habitats. And as the dream of colonizing space slowly morphs into strategy and science, artificial gravity becomes not just an innovation, but a necessity. It's the difference between short visits and long-term presence, between exploration and settlement, between surviving space and thriving in it. So, where do we go from here? Around the world, scientists, engineers, and space agencies are pushing the boundaries of what's possible. From lab-based centrifuges to conceptual space station designs, the work is underway. It's not easy. It won't happen overnight. But step by step, rotation by rotation, we're bringing gravity back to the stars. As we continue this journey into the unknown, artificial gravity represents more than technology. It reflects humanity's refusal to be confined by nature's rules. Our hunger to adapt, evolve, and reach farther than ever before. It is the echo of a species destined to leave Earth, and determined to take a piece of it with us.